Hello everyone, welcome to the Computer Networks lecture series. In this particular session, we'll study about the network models. So, before starting with the network models, let us see what is the meaning of protocol layering. So, we have the first scenario. This network models, they are based on layers, different layers. So, before coming to those layers, let us study the basics of protocol layering. So, we have a scenario, single layer where two persons they are communicating. So one on the left side, she can talk and listen. On the right side, she can talk and listen. So when the person on left, when she is talking, the person on the right, she listens. And when the person on the right is talking, the person on the left listens. So in this particular scenario, both are physically present at a particular place, and when one is talking, the other is listening, and one is listening, the other is talking. So we have in the single layer talk, listen, and listen, talk. Now consider the second scenario where we have three layers between the two entities. So the first layer is read write, the second is encryption decryption, and the third is send and receive mail. So these two persons, now they are not at a particular place, but they are far apart. So the person on the left, she writes a letter and then encrypts the letter so that nobody else is able to read the contents, and then she sends the mail. The mail is received by the person on the right side. Okay, she decrypts the message so that she can recover the plain text, and then she reads the message. So here we have three layers. Layer 1 is read write, layer 2 encryption decryption, layer 3 send and receive. So after the first layer, the person on the left, she writes the letter, and that letter is in readable format. So because it is in readable format, it is called as the plain text. She encrypts the message and it becomes a cipher text. So cipher text is a message which cannot be understood by anyone except the one which is intended to. And then in the third layer, this cipher text is sent through the mail. It is received on the right side. Then the receiver receives the cipher text, so she need to convert it to plain text. So she decrypts the message and recovers the plain text, and she gets the message. So here, as we can see, at layer 1 we have read write operation, at layer 2 we have encryption decryption, and at layer 3 we have send and receive mail. And regarding the data, at the layer 1 we have plain text at both the ends, at layer 2 we have cipher text at both the ends, and at layer 3 we have mails at both the ends. So what are the principles regarding what we studied in the previous slides? What we understand from the principles of protocol layering is that the first principle is each layer must perform two opposite tasks. In this case, read write. So at the first layer we have read write, and second we have encrypt decrypt, and third we have send receive. So we have two opposite tasks. As we can see, read opposite is write, encrypt opposite is decrypt, send opposite is receive. Then what the second principle says, the two objects under each layer at both sides should be identical. As we saw, at the first layer we had the plain text, at the second layer we had the cipher text, at the third layer we had the mail. So this we can assume to be the logical connection. So the first layer is logically connected of the left is connected to the right one. The second layer is logically of the left side is logically connected to the right side, and similarly the third layer, logical connection between the third layer at the both the ends. Now we come to the topic, that is the networking model. So we have the TCP/IP protocol. Okay, so there are 5 layers at the TCP/IP. Each layer has its own functionalities. The first layer is the physical layer. We'll study this in detail in the coming sessions. Then we have the second layer as the data link layer. Then the third layer is the network layer. The fourth is the transport. The fifth is the application layer. So this all layers, they have their own protocols, their own functionalities. Now this is a simple network. Here we have host A. Host A is connected to host B through a switch and a router. So because they are at two different networks, so we need a router. Okay. So in the layered architecture, how do we observe? At host A, we have all the 5 layers, that is the application, the transport, the network, the data link, the physical layer. And similarly at host B, we also have all the 5 layers. Then if we observe the previous diagram, we had a switch and we had a router. So switch operates at the data link layer. So there are 2 layers here, physical and data link. And router, it operates at the network layer. So here we have, see, what we observe is that the data starts, as we can see with the arrow, the data starts with host A, with the application layer. This data is passed through the transport layer at host A, then network, then data link, then physical. Then from the physical media, it is passed to the switch at the physical layer of the switch, then goes to the data link layer, then comes back to the router physical layer, and so on, and until it reaches the application layer of host B. So this is how this is done through the layered architecture. That is what we observe through the layered architecture. Now we have different definitions of data at each layer. So at the physical layer, the data is identified as bits. At the data link layer, the data is identified as frames. At network layer, the data is identified as datagrams, or we can say them as packets. At transport layer, the data is identified either as a segment or a user datagram. And at the application, we have message. So at each and every layer, we have different definitions of the data. Starting from physical, we have bits, then frames, then datagrams, packets, segments, and messages. We will study them in detail when we come to the layers. Now, what are the various functionalities of each and every layer? So the first layer is the physical layer. So physical is the lowest layer in TCP/IP model. So it focuses on raw bit transmission, so that the data is transmitted at this particular layer. Now it specifies, so the physical layer, it specifies the hardware characteristics such as how would be the electrical signals, what voltage level should be there to define the signals, the various connectors, the various transmission medias. Now transmission medias, of course, it can be either a copper wire or fiber optic or wireless signals. And of course physical layer ensures the data is transmitted through the medium properly. Then we have the data link layer. So data link layer, it ensures that data frame is properly transmitted between the two medias, physical medium. Okay. And so there are various protocols and there are standards which are used for framing, error detection, and flow control. We'll study what is the meaning of framing, what is error detection and flow control when we study this data link layer in detail. Then some of the common protocols is the Ethernet, the Wi-Fi, and point-to-point protocols which are used at data link layer. Now this particular layer is also responsible to maintain the integrity, so that if there is any change, if there is any error, the error is detected. Then we have the network layer. So this network layer, the main function is of course routing and forwarding the packets across the networks. So at the network layer, we are using the logical addressing. So network layer also determines the best possible path for the packets from host to the final destination. Then of course there are various protocols within the network layer which define the addressing, the routing, fragmentation, reassembly. Of course we will study them in detail. Now one of the important protocol at network is the IP. So we have this TCP IP. So IP is actually internet protocol. Then we have the transport layer. So transport layer, it ensures reliable delivery of data between two hosts. So it is like process to process communication. So the protocols which are used at transport layer, one of them is TCP, as we have seen, TCP IP. So this TCP is this transmission control protocol, and we also have UDP. Then TCP is a reliable protocol and it is connection oriented. It has features such as error connection, flow control, etc., congestion control. And UDP, it is a unreliable protocol, and connectionless protocol. We will study them in detail in the coming chapters. Now finally we have the application layer. So application layer, there are many applications and there are various services which are available at the application layer. Just like we are using email, so email is a service which is provided at the application layer. Then we have various file transfer protocol, then we do web browsing, then we have DNS, and there are many other protocols which are used. So these protocols, they enable that there is a proper interaction between the host and the between the two hosts, maybe like client and server. So of course this application layer is important in supporting various functionalities across the networks and provide various services. Now we have a concept called as encapsulation and decapsulation. What this is actually, so we have this 5 layers, TCP layers. So we have application, transport, network, data link, physical at both the ends. So first of all, the application starts, let us say M is a message. It starts from the application layer. It is given to the transport layer. Transport layer, it adds its header, okay, and it passes to network layer. Then network layer, it adds its own header, okay, and passes it to data link layer. Then at data link layer, of course, it also adds its own header and passes it to the physical layer. Then this message is transferred to the final destination. Okay, from physical it goes to the data link. Now as we can see, this H, which is in orange box, H which was added by data link layer at the source. Now this header is removed at the destination, and when it goes to the network, the header which was added by the sending host at the network layer is removed by the destination network layer. And similarly, the transport layer also removes this header. So and finally we get this message at the application. So here encapsulation means what? We are forming a capsule. So this M is actually added this message. We add a header at each and every layer, and that is called as encapsulation. And at the receiving end, it is decapsulated. So we just remove the header. Now this header, it contains some vital information that we will discuss while discussing each and every layer. Now various addressing are used at this particular layer. At the application, the addressing used is the names, like we have www.google.com and so on. So various we address the names, we identify various websites by its name. So we have domain name, we have email IDs. So this is the names which we are using at the application layer. At the transport layer, we have the port numbers. So transport layer, it is actually interaction between the processes, and processes, they are identified by the port numbers. Then at the network layer, we have the logical address, which is also called as the IP address. So every machine has its own unique IP address. Then at the data link layer, we have the physical address, which is also called as the MAC address. So these are the 4 addresses which we are using at the TCP protocol. Now apart from TCP/IP, we also have OSI model. So in OSI model, we have this different layers: the application layer, the presentation layer, the session layer, the transport layer, network layer, data link, as well as the physical. So there are 7 layers in the OSI model. So if we compare this OSI model with TCP/IP, we can see this is what we get. So physical layer are present in both the cases, data link layer present in, of course they have this almost similar functionalities. Only the difference is that session and presentation layer, they are there in OSI, but they are absent in TCP/IP. So while while designing this OSI, these people, the one who designed, they also added these 2 layers, that is the presentation and the session layers. And in TCP/IP, all these things, they are covered by the application layer itself. Now OSI model did not succeed. There are some reasons why it did not succeed. The first is OSI model came after TCP/IP. So TCP/IP came first, then OSI was designed. So experts thought that OSI would replace TCP/IP, but it did not happen. The reason was OSI was ready when TCP/IP was already popular. So of course, changing the previous TCP/IP would bear a lot amount of cost. So OSI was not implemented. The second was some of the layers in OSI, they were not fully explained. just like as we saw in the previous, we had presentation in the session layer, they were not fully explained. So when many organizations, they tried to replace this OSI with TCP/IP, but it did not work well. So these were the reasons of the success of TCP/IP. So that's all for this particular session. Thanks for watching. Do join for the next video.